So in this video, I want to describe how to create attractor points in Grasshopper. An attractor point describes an effect where a grid of objects deforms based on the proximity to a specific point or a series of points. As you can see in these examples, if you just simply surf through internet, you'll see a lot of examples where the size of the perforation or the density of a wave is determined based on the proximity of, for example, centroid of those perforations, or the angle of some objects in relation to a predefined points. And in this video, we're going to explore how to create some simple examples of this kind of effects. Just to show you a couple of examples, you see that the size of the perforations might be changed based on the proximity to some specific points, and we're going to work on one example in this video and another in a different video. So okay, now let's get started with a simple example. First of all, we want to create a grid of objects. That grid can be created in the format of a hexagon or a rectangle. I go to vectors, hexagonal grid. It asks for a plane, XY plane. This is a plane. I turn the preview off. And then the next thing is that it asks for the size and extends along x-axis and y-axis. So I will just copy this. So I will go with a radius of 1. We can change it to even a number slider, for example, 1 to 10. And then the number of iterations can vary, for example, from 1 to 50 in any of the two directions. Okay. Now I want to create a surface, and I want to offset these hexagonal shapes inside and create a surface while the inner hexagon is perforated. So what I'm going to do is I'm going to find a polygon center, and then I'm going to connect the cells to it. So I'm going to get the center point of each of these cells, and then I'm going to scale down these hexagonal forms with the scale point with the base point of the center. So I'm going to say, okay, scale down these geometries, and I'm going to use basically this. So in this situation, you will see that all the cells are just offset inside with a factor. We'll just put a factor of 1.1 to, for example, 5. You see, they're all in the same size. Now I want to change this scaling factor based on the proximity of these center points to some certain points. What I'm going to do, I'm going to drop some points onto the canvas. You can either drop some points in the rhino and then say, for example, these are the points, and then set 1 point or set multiple points. And for example, pick some points on the Rhino viewport, or you can define some parametric points. You can define parametric points by calling construct points by giving the x, y, z coordinates. And what I'm going to do, so here are, this is the first point and this is the second. Okay. What I'm going to do, I'm going to actually find the distance between this point, I mean, these series of points, I have 270 points, and this point. And based on the distance, so I'm going to get a series of values. Based on this point, I define a mathematical relation. So I would say whatever distance is between these points and the points that I'm getting, I want to divide, just a simple math divide. I'm going to divide this distance by a number. And since I don't know how much might be that number, I just go with a great maximum value, like 100, for example. And then instead of connecting a factor with a number slider, I connect this. Now, you see, let's just reduce this. So now, you see, based on the proximity of these center points to this single point that I defined here, I can change the size of those inner hexagonal shapes. Okay, and if you want to create a surface, you can just simply draw surface, say that is a geometry that I have, and then you can see that kind of attractor point effect. If you want to add another attractor point, there are different ways to do that. You can actually, in this example, for example, connect another distance component and compare the distance of, for example, this point with the center centroid. And this time I will just add the addition component and add these two addition values and then connect the result with this division component. So then when I move this point, you will see the effect of the attractor points vary depending on the position of those 2 points. You see? So now you're involving 2 attractor points, and you need to play around with the position of these 2 points to find the most suitable pattern that you're looking for. Now, this is the simplest example of creating the attractor point effect. In the next video, I'm going to demonstrate another example of defining this proximity relation between certain objects and a series of attractor points.